the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
Stevens Institute of Technology is proud to present the Hugo New Corporation Sustainability Seminar Series, co-sponsored by Geocentric Consultants, H2M Architect Engineers, Brown and Codwell, and BEM Systems.
Hey guys, hopefully you're taking all the necessary precautions and keeping yourselves safe. Those of you who had plans for spring break, try not to overindulge. Next week is going to be tough. And I don't know what's going to happen after next week, because most of the colleges and universities, they have decided to go completely online for at least 2 more weeks after the spring break. So I do not know what our administration will do, but most likely we are going to do this seminar online, at least 1 week after the spring break. All right, so I'll just, I'll try to figure out what's going on campus, and then I'll keep you posted. You'll see, again, whatever decisions they make, you'll get that. Plus, I'm going to upload in Canvas any announcement that I have. So in that case, let me introduce today's speaker, Ken Span. Ken joined Dewberry in October 2014. Prior to Dewberry, Ken held senior leadership positions with Port Authority of New York and New Jersey over a 30-year career. Since joining Dewberry, Ken has been involved in a number of projects and resiliency efforts, including the role of project manager for the landmark Rebuild by Design Hudson River feasibility study and environmental impact statement project. This is the project he's going to talk about today. Ken graduated from SUNY Maritime College with a Bachelor of Science in Marine Transportation and obtained a Master of Science degree in Management Engineering from NJIT. He is a project management professional and served on the board of the Maritime Association of the Port of New York and New Jersey. So without any further ado, Ken, please take it from here.
Thank you so much, Dibs. And I'm honored to be the first guinea pig. Honored to be the first person to be doing this remotely. So just to go over what we're going to talk about today, I'm going to touch on Superstorm Sandy because I figured you guys have probably heard a lot about that, but I'm going to give it a little bit from my perspective. Talk about the Rebuild by Design competition. That was a large competition for the tri-state area. And then talk about the Rebuild by Design Hudson River project, which is the project that was Hoboken, Weehawken, and Jersey City. Get into the feasibility aspects and the NEPA process, all the public outreach, how we got to a preferred alternative, and then talk about and show you some of the results from the flood modeling for storm surge and rainfall. So good old hurricane or Superstorm Sandy, I guess. Technically, I've heard both things. I think when it hit, it was technically a Category 1 hurricane. And it hit, the center of it was right about in Brigantine, New Jersey. And it was really the worst possible situation because the right side of the storm kind of lined up perfectly with New York Harbor between Sandy Hook and Long Island, which created a funnel effect. So we were lucky it was only a Category 1, because it also hit at high tide on a full moon tide. So tides were normal, higher than normal at the time. And so we ended up with, 13.88 inches or no, 13.88 feet above normal at the battery. So it truly was a difficult storm. The amazing thing about it too is it did not bring much rainfall, so it really could have been worse. But it was really an awakening for everyone. And so I want to talk a little bit about what I was doing then. At the time, I was in the Port Authority of New York and New Jersey, and I was responsible for the recovery from Superstorm Sandy. So this image is a guy. It's not me, but it's a guy that was working with me. We were doing surveys of all the facilities to look at the damage. And this is in Port Jersey, right on the Hudson River. And you can see how high the water was along that fence line there, where the whole facility was underwater. And then these are just some images from the port, because I was so closely involved with it, I figured I'd share it. Containers were strewn all over the place. Containers ended up in the water. We had a barge up on the dock in Port Newark, the bottom left. You can see the date, November 1st. We also had a snowstorm about a couple days after Sandy that was sort of insult to injury. And then the bottom right, we had a lot of asphalt torn up out in Port Jersey as well. We had several 100,000 vehicles that were destroyed as a result of the storm. These were brand new vehicles imported into the port. There were Teslas that started coming into the port that got wet as well. And after they started to dry out, there was some corrosive reaction between the batteries and the salt water, and they actually burst into flames. So it was an interesting time. The port was closed for about 6 days, but it really took 6 months for the port to fully recover. So then we're going to move on to the Rebuild by Design competition. So I just want to talk about it because I think it's an example of good government. After Sandy in June of 2013, the Housing and Urban Development Division of the United States government, we'll call it, launched the Rebuild by Design competition. And it's a multi-stage planning and design competition to promote resilience in the Sandy affected region. So HUD administered the competition in partnership with philanthropic organizations, academic and nonprofit organizations. It was really Rockefeller Foundation had a lot to do with it, and Rockefeller Foundation put the money up for the stipends for the consulting teams to kind of get paid for the work they were doing to come up with their different ideas on how these different regional areas could recover from or prevent a Sandy in the future. The goal of the competition was to promote innovation by developing regionally scalable but locally contextual solutions that increase resilience in the region. So in 2014, June 2014, $930 million was awarded to 7 different projects. I think there was a total of 10 that were actually submitted, and 7 of them received money. And one of those was the Rebuild by Design Hudson River project, which was for Hoboken, Weehawken, and Jersey City, which we're going to talk about. I love this image because this image was in the package that was submitted for the competition, and it shows a hot air balloon in the background. It shows a very active waterfront area. It shows, an elevated area and people walking around and kayaking and so forth. But it was great to win a competition, but this image is not in reality what was really practically could be sort of designed and implemented. It's just not, and we'll talk about that a little bit, because there's just because of the costs of waterfront work, because of the ownership of the waterfront, because of the impacts to view sheds and different things like that. It's a wonderful image, but not really realistic, but it won the competition. So that's great. So the other main theme of the winning competition, and is what we had to start with when we started our feasibility and NEPA process, is resist, delay, store, and discharge, RDSD. And the idea is to develop a comprehensive urban water strategy by creating infrastructure to resist storm surge coming in like it did before, and also infrastructure to delay rainfall getting into the storm system, potentially store rainfall so that it's not overwhelming the storm system, because in Hoboken you actually have a combined sanitary and storm system, and it's ancient, so it does not drain properly. So they need more capacity in the system. So the idea was to delay it, to store it, and then also to discharge it mechanically into the river to get it out, so you could make more room for additional capacity. But that was the key to this project: resist, delay, store, discharge. So to talk a little bit about the study area, City of Hoboken, parts of Jersey City, Weehawken, about 1.8 square miles. The population there, roughly 63,000 people. This was a number of years back when we started this. There's a major transportation hub in the New Jersey Transit at the south end. Trying to find my cursor here. Down at the south end, there's a little blue line. I don't know if it's very obvious, but that shows the project area up in here. This is Weehawken, of course, Hoboken in the center, that you all know well, and then Jersey City down at the south end. High residential density. It's one of the most densely populated areas in the US. Super active recreational waterfront that we learned a lot about through this project. And then the other piece of it is an aging infrastructure. The waterfront infrastructure is not in the greatest shape. So if you're going to build anything on the waterfront, you really need to rebuild the waterfront. And then the inland infrastructure, in terms, I mentioned already, the sanitary system, the storm system is old. And you guys probably hear about water main breaks in Hoboken. So flooding risks in this area, the top two images are from Hurricane Sandy, and you can see going underneath the bridges coming into Hoboken from Jersey City. The area was just inundated with flood water. Luckily, it didn't rain much. It could have been worse. And then Hurricane Irene did not have the storm surge effect that Hurricane Sandy had. It hit at a low tide. However, they dumped in a very short period of time over 5 inches of rain. So there were some areas in Hurricane Irene flooded almost as bad as they were during Sandy. So why do we need the project? And this is a map that shows the 100-year FEMA flood area. It's in blue. And so most of Hoboken is in that 1% annual chance. So that means that there's a 1% chance basically every day of the year of this 100-year storm coming and flooding that area that's in blue. Where Stevens is located, Castle Point is the highest area in the city. And I'm told that when the Dutch settled this area, a lot of that area in blue was swampland, and it was filled in over the years. So that Castle Point was more of an island. Then there's some crosshatched areas that show where we have rainfall problems, where when there's no storm surge, but then you get a heavy rainstorm. These are hot spots where it's a problem for localized. The damage from those rainstorms is not like the damage you get from a major storm surge, but it's still nuisance flooding that needed to be addressed with this project as well. So I'm just going to kind of show you the 100-year storm, and this is very similar to Sandy coming into this area. I don't know if you've seen this, but this is modeling we did. We use Mike 21 modeling program. So you can see at the top, the little box and the sine wave graph shows sort of the time of this, but this flooding occurred over, in a period of a half hour. It came in, and it comes in the south end and the north end, and then sort of meets in the middle. So the low areas are in the south area by Long Slip Canal and the Hoboken train terminal, and then also low area at Weehawken Cove. And then it also inundated Jersey City through Long Slip Canal. And so this is what we're faced with. This is similar to how we modeled Sandy as well, and it's pretty close to a 1% annual chance storm. Some people debate that, but that's how the water gets into the area. So to talk about the overall project schedule, when we started the project, so the Rebuild by Design competition was in June 2014. It took about a year for that award to get made, and then some time for us to get on board and start the feasibility and NEPA process, which was really a 2-year process, which when you think about it is a very short process for NEPA. And what is key to this is the engineers working on the feasibility have to work very closely with the planners that are working on the NEPA process, because the information really feeds the process. The engineering information feeds the NEPA process. So that's really important for them to be in sync in order for us to compress the schedule. Often this could take 5 years, or often a lot of the engineering work needs to be done up front before you can even really get into the NEPA process. And then the final design has been going on. It's pushed out a little bit. I think they're getting ready to award a construction this year, not 2019. That's not surprising because this is a very complicated project. So just to talk a little bit about NEPA, I mean, what it is, NEPA was created by an act of Congress and authorized by President Nixon in 1969. And the idea is it ensures public participation and involvement with projects that will affect both the built and natural environment. And the idea is to minimize impacts and stimulate health and welfare of man and the ecosystems. So anytime you're doing a project, particularly with using federal dollars, which is what this 230 million is, you've got to go through NEPA. Whether that changes in the future or not, who knows? But you start out, what is the purpose and need? And the idea is to get people, you'll see public involvement is key to the entire process, and people that live and work in these areas agree why we're doing this and why we need it. You need to develop your scoping. In other words, what are the goals of the project? How do you want to end up, and what are the deliverables? And then talk about what's the environment that's affected, and what are the impacts, and how can you mitigate it? And then look through different alternatives and different ideas. And then finally come up with a preferred alternative, and then there is an actual record of decision where there is a public hearing. And it's actually the only required public hearing for the record of decision, but actually it's better practice to have several public hearings through the process. Once the record of decision is signed, then the project is approved to move forward. So looking at the combined schedule of feasibility and NEPA, you can see that we're sort of doing our feasibility assessment as we're doing the NEPA process. And again, the key piece of it is the public involvement. So the notice of intent is the official notice that NEPA is starting. And then we went through a number of different meetings and sections where we identified purpose and need, scoping, developed some metrics for doing screening of different concepts, and then an alternative analysis for concepts. And then we developed a draft EIS and a final EIS, and then the ROD, record of decision. As I mentioned before, public involvement is key to this NEPA process, and it's really key to any project. And I know through the design effort that they've been doing over the last couple of years, there's been a lot of public involvement. It just continued, and during construction, there will be a lot of public involvement because it's just not going to be successful without it. How we set it up is we had community advisory group meetings, which initially were certain different leadership people from different parts of the community, from Weehawken, from Jersey City, and a lot from Hoboken, since all of Hoboken was involved in this project. We had public meetings, probably had about 4 or 5 large public meetings that we notified every one of them, and it was open attendance. And then we also had workshops where we could, with smaller groups, work with people in local areas in one block possibly, where we're looking at making some changes to get their feedback on what they'd like to see. So it was really a combination. We had probably over 90 meetings between public meetings, workshops, CAG meetings, and then also outreach to different municipal leaderships and different things. It's important to communicate to the public in language they can understand. So we had the website set up where people can go to the website and see what's happening. We handed out what we call frequently asked questions brochures. People had questions on, what's going to happen to our parking? What's the impact to my home? What are our property values going to get impacted? There's community concerns. There's timelines. There's many questions that people have. So kind of really have to be in tune to what kind of questions they're going to ask and really make the answers to those questions available. So our roadmap to a preferred alternative, we started with data collection initially after the notice of intent, and that's kind of doing your base mapping, your waterfront inspections to look at the condition of the waterfront, getting geotechnical information to understand if you have the ability for for rainwater to be absorbed into the ground, and the reality in this region is that the water table was very high, so there's very little natural attenuation available. We had to do work to set up our modeling, and then also there was an awful lot of work to collect information as far as potential resist features and different types of infrastructure that could be applied. You sort of took all that information and developed, okay, well, what's suitable? What different approaches make sense? And we developed a toolkit. What different types of resist features make sense? Large berms. I mean, we finally came to the realization that whatever we would build would have to certainly fit into the culture and the aesthetics of the landscape. And then different themes that you'd want to sort of develop into whatever you're building. So we sort of rolled that together and then developed concepts. And for our project, we had 5 different concepts that sort of represented a range of different approaches. Some obviously were less popular than others, but we just wanted to make sure we were covering sort of the gamut. And then we narrowed down those 5 concepts based on input from the public and others that have major stake to 3 alternatives. And then towards the end, we moved into a preferred alternative. Things you need to consider when you're developing the different components of this is, what are the existing initiatives? At the time, Hoboken was just starting the redevelopment of Washington Street. Some things it's okay to be wet. Some things have to be dry. There was a boathouse being planned for the Weehawken Cove or Hoboken Cove area. How would it impact bike share programs? What are the impacts with the views and the height? Are there shading issues? What's the seasonability? What sort of material, would be appropriate to use to maintain the urban identity? So some of the major challenges with this project is, number one, it was a very active waterfront. So we learned pretty early on in the project that doing things along the waterfront were going to be difficult for a number of reasons. Mainly existing access that people have, views that people have, condition of the waterfront, property rights of the waterfront. But really, it was sort of a sanctity to not do anything to impact access and availability of the waterfront. The roadways and bridges, it's just a busy area through Hoboken. And when you're looking to create basically a flood revetment around the city or around the project area, you want it to get certified by FEMA so that folks that are on the other side of that revetment will get a reduction in their insurance rates possibly. So roadways create, through the area, and particularly through wherever the resist features are, create a pathway for water. So it just made it tricky. And then infrastructure density, there's just not a lot of space to build anything in this project area. So it did create some challenges. Circulation is also a major issue. Just for constructability, it's a major issue. And just, things like impacting the number of parking spaces because they're near and dear to people. So it's important to maintain circulation with whatever you're doing. So the evaluation criteria we were using, the primary evaluation criteria is the flood risk reduction. We have alternative 1, 2, 3. And what level of flood risk do you get from each alternative and how do they compare? What are the socioeconomic and built environment impacts of the different alternatives? How does it affect lower income neighborhoods? How does it affect the waterfront areas? Then benefit cost analysis is really important when it comes to funding from the federal government. To have a positive benefit cost analysis. So out of the different alternatives, you have construction estimates, cost estimates, and you have the impact of the storm. And so what costs are you averting by making this investment, and what does that come out to in terms of your ratio for your benefit cost analysis? And then, is it constructible? And can you maintain it and operate it? Those are all factors that you're considering when you're evaluating criteria for a different alternative, and then ultimately environmental impacts get looked at across a broad range of different environmental type issues. So the three resist alternatives that we came up with was, alternative one was the waterfront, and you can see the orange line, and it's, it would be a rather high structure. Now, the structure could be built into the landscape at some levels, but some areas there really wasn't enough room other than it just being a structure. And one of the things we learned, we don't call these things walls. These are resist features. But the reality is, in some areas where there isn't room to do anything else, and some of these areas along the waterfront, you'd end up, okay, it'd be a nice looking wall, but it would end up being a wall. And that is not something that's preferred by people. The second alternative was most of these alternatives started at the north end and tied into the Weehawken light rail station. But, as you can see, the orange one comes down along the waterfront. The alternative 2 and alternative 3 are more like inland alternatives, very similar. One goes along 19th Street, one stays kind of along the light rail tracks. Then they all come across Weehawken Cove similarly. The idea was, there's an empty lot here, so the idea is to build a park and build into that park a resist feature, an elevator resist feature, and then the alleyway actually comes down through an alleyway where there are no vehicles. So there was definitely some benefits to this, because it does not affect the roadways or parking or anything coming through that alleyway. The other one was to go up a little further and come across onto Washington Street. At the south end, the alternatives were very similar because there weren't many options. One of the things we looked at that we had to not consider, it was probably in one of our 5 initial concepts, was to build something through the New Jersey Transit Station. But New Jersey Transit Station is very low. There's an issue there, and someday something has to be done about that. But it's just the cost of elevating that station is just higher than the amount of money we had budgeted for this project. And the ability to build a revetment through there, when you've got trains that have to get in and out and people that have to get in and out, it's just, the cost is pretty astronomical. So we were kind of limited at the south end, and we had 3 variations on a main theme, and these are all revetments that would be built into the infrastructure there at low points to prevent flooding from getting beyond like where the New Jersey Transit tracks are. What was ultimately decided on, there's been some minor tweaks to this, but it's very similar to this, that what they will be building. There's also some work being done in the southwest corner where the light rail tracks kind of swing around and go underneath the transit tracks. It's a low point there too. So also for delay, store, and discharge, we really only had one alternative for that. Unlike the resist feature, there were some different ideas, but there were basically known areas that flooded in the project area. And so there just weren't as many alternatives. So what we looked at was what we called at the time the BASF site, putting in a below ground storage tank to handle rainfall runoff for the area in the northwest up in here, in this area. And so that just recently has been, it's going into construction. There was just a press release a few weeks ago. They call it the Northwest Resiliency Park. And so that's actually happening now. And the city of Hoboken was able to move that forward because there wasn't money for that in the Rebuild by Design grant. There was only money for really the resist feature. The idea behind the Rebuild by Design grant was to kind of jumpstart things, but some of what's being recommended here has to be followed up by the local community. We also looked at a New Jersey Transit site for storage of water in an area that floods in these apartments back here. Just calling it New Jersey Transit site because New Jersey Transit happens to own the property. And also a Block 10 site, which is adjacent to the Southwest Resiliency Park. And then also a number of what we call right-of-way green or gray infrastructure projects. These are small little X's on the image you see that would create additional capacity for different storm drain inlets where there is known to be flooding. So just to buy some time where that water would have an area to be held so that it wouldn't overflow onto the streets in these localized flooding areas. There's also a number of things the city of Hoboken has done, and the city of Hoboken is really trying to do a lot to improve flooding, particularly from rainfall. They've added pump stations down in the south end, and a few years ago completed H5 pump station. They've added some rainfall water gardens on Washington Street, and I mentioned the Southwest Resilient. So things are moving in the right direction in Hoboken. So the preferred alternative is the alleyway alternative that goes from the light rail station in Weehawken down along across the cove and up a ways onto Washington Street. And then there's a couple of options. They're actually moving to something like option 1 on here. And then also all the resist, delay, store, and discharge pieces. Alternative 3 had a high degree of flood risk reduction while balancing public input and costs and urban amenities. It can be constructed with the available funds. I think actually that's going to be a stretch. They may need some additional funds, but it was the cheapest alternative. It had less gates because gates are expensive and gates are maintenance items. So it had the fewest number of gates than any of the other alternatives. So it's the lowest annual maintenance and the least impact to the waterfront access and views, which is critical to the folks that live there. So some of the delay, store, discharge alternative features was the Northwest Resiliency is more like a destination, a place where people would go, can picnic and can hang out for a while. We looked at more of a passive thing for the New Jersey Transit site, where it's more of something you can look at and creates a green area for that can hold water. And then the Southwest Resiliency and Block 10 is more of an active area where there's going to be some basketball courts and things like that. And then the right-of-way sites we talked about are just local little things where there could be some bio attenuation of water into the storm drain or something else I'll show you in a minute. This is actually an image of the Northwest Resiliency Park that is moving forward today. So quickly going to do I'm going to do it. Do some modeling here. It's not working. Dibs, are these technical problems you were talking about?
Oh, this one looks more like.
Oh wait, yeah, I'm sorry, I have the wrong one. You're right. Very good.
Yeah, this is not
Come here.
that one.
So comparing the flooding. So this is a 5-year rainfall event happening during high tide. It matters whether it's high tide or low tide because the storm system fills with water during high tide, so there's less capacity for water. So on the left is the baseline conditions with no action, and on the right is when we install the delay, store, discharge alternatives. And you can see there's less blue on the right than the left, so that there's significant improvement with the Northwest Resiliency Park, with the New Jersey Transit site, with the Block 10 site, and these small right-of-way improvements. And so this is the model here of what we're calling the right-of-way improvement, where you'll see water going into the catch basin, and there's a tank sort of accompanying it. And when it starts to rain, it's a little bit slow. Water fills up. Water goes into this hole through the weir, And so it allows water to sort of get into the storm drain system, but it slows it down. In the meantime, you've got capacity to hold the water. You can see it's filling up. So you get these summertime deluges that come along. And so rather than it backing up onto the street right away because there isn't capacity in the system, you can hold some of it. But at some point, these local tanks will fill up and they'll spill over top of the weir. But it's just an improvement that kind of adds to the overall resiliency of the area. So just to quickly go through the layout of the alignment for the resist feature, it comes through the park here. It goes up Garden Street and then through an alleyway through these buildings where there are no vehicles, and then up Washington just past 14th. And of course, the idea is to build something here that fits into the elements and the culture and the aesthetics of the existing buildings and existing activity that's happening there. This is sort of a before picture of where the park is going to go. As I said earlier, it's an empty lot today, and then this is what it will look like in the future. This is along Garden Street, up against a parking garage. And so that planner, and this may not be exactly what it ends up being because they've spent the last couple of years refining exactly what sort of a revetment they're going to put here, resist feature. But this is something that we came up with that people were satisfied with. It could change a little bit from this. And then this is looking, there's an open air market right off Garden Street. Garden Street's kind of a dead end. And so this is like the area of the open air market, and we're looking into the alleyway that's heading east. And so this brown planter is an idea for the resist barrier. In that area, the resist barrier is only 2-3 feet high, maybe. This is the area to the north by the Weehawken train station, and it's the before, and then it's the after. And you can see the height of that element there is pretty high because that's a very low area. Okay, here's what I was looking for before. So on the left is the 100-year storm happening without the project, and on the right is the storm happening with the project. You can see on the left, the water coming in at the bottom and the top, meeting in the center. On the right, now the interesting thing about this, because we spent a lot of time with Jersey City, because Jersey City has their own issues, and they want to know, okay, well, we build this resist feature, you know, in Hoboken and parts of Jersey City. What's gonna happen to Jersey City? Is it gonna make our flooding worse? And the reality is it improves it, because you don't get all that water coming down through Hoboken and all that water coming through Jersey Transit Station into Jersey City. So you can see the different color codes here, you know, where there's like here, 3 to 6 feet of water in Jersey City in a lot of areas, and here there's a lot less. So even though these areas are outside the project area, they're benefiting from that deluge that comes from the north and comes in from the south, and then ends up into the lower areas. And as I had mentioned, these areas of the western part of Hoboken, and the problem with Sandy was that they're lower. The elevation is lower there, and so water just kind of fills in and sits there. So this is an animation of the resist feature, and it's kind of a flyover of it. And this is kind of what we used during the process so people get an idea what it might look like. Think of Rocky theme music while you're watching this. So we're zooming into the Weehawken area. And we're looking at along the light rail tracks, you'll see a revetment in that area. And then we're coming across into the Weehawken, Hoboken Cove area. And on the right, there's the boathouse and the park will be constructed over the next few years. And there's sort of a curved spine through the center of it, which is the elevated piece. The other thing you'll see is some images of gates. This is looking up Garden Street. There's a gate kind of coming across 15th Street. These gates, the design will be set back into the resist feature. So when the gates aren't being used, you won't see them. This is the alleyway area, and this was an idea for the alleyway. And again, this is part of the alleyway. There goes the gate. And now we're going up Washington Street, just past 14th. The interesting thing is a lot of the structures that are along the water, the first floor of those structures are parking. And so they really weren't impacted by Sandy. So the people that live in those high rises, you know, really didn't care that they're outside of the flood zone because where they live is above the flood zone. So suppose they can move their cars. So here you can see the resist feature getting higher as you get to a lower area. So we started a little bit up Washington Avenue, and then it peaks in this area in terms of the height that it needs to be. And then we come along the New Jersey Transit Station where there's two different alternatives. At the time of this, there were two different alternatives. And we were leaving it to the people that live and work in the area to determine exactly what they want these features to look like. But we just sort of kind of gave them different ideas. There isn't a lot of room to do a lot here, but there were two different alternatives, and they finally decided on one, which is a little bit of a modification of these two. And then this is the southwest area where the the light rail tracks go underneath the New Jersey Transit tracks that leave Hoboken. So that is my presentation.